Hello and welcome to another SolidWorks how-to video. In this video, we're going to go a little further into assemblies and specifically in-context references for parts. I feel like this video should come with a big disclaimer in that while this method is perfectly valid, it is solid, and it can save you a ton of time in creating the parts that go into an assembly. The disclaimer is that I don't actually recommend doing it. And we'll talk about that sort of later on. There's one major drawback to this method that leads me to actually recommend that you use the long way and just create the parts separately and then bring them into an assembly rather than what we're going to talk around about here. But it is a perfectly, like I said, perfectly valid method of modeling assemblies in SolidWorks, and it can be very, very fast. So we'll talk about it, and then I'll sort of go through the one major drawback that leads me to that disclaimer that I don't actually recommend doing this in most cases. So rather than start with a part this time, I'm going to start out with an assembly. So I just clicked New Assembly in SolidWorks. We'll give it a minute to think and create my assembly, get everything caught up. I don't want to open a part. I want to start from scratch. So I'm going to even go ahead and hit the red X over on the left side of my screen where it says begin assembly and close that. Now, up on the assembly tab on my ribbon, under insert components, instead of insert, because if I just insert, it wants me to open a part, and that's the normal way we would start an assembly. I'm going to close this, and again, close insert. On this drop down though, I'm just going to hit new part. Now I have a new part. It's created, and actually I have to click. I have a green check mark on my mouse, so a click to accept it. I have a new part. That part is fixed because again, the first part that comes into an assembly is always fixed, and it happens to be fixed wherever we create it. And there's a part here, but there's no information. I haven't actually built it yet. So I'm going to go ahead and right click, and I'm going to edit part. Now that it's highlighted in blue here in my feature manager, I can expand it and show all the rest of these are blue. Now I can go ahead inside this assembly. Now that this is blue and I'm editing this part, I can go ahead and create the part the same way that I would any other part that I would be bringing into the assembly. So this is sort of in context part creation. I'm building the part that never existed before, and I'm building it right inside the assembly. So I'm going to keep this one sort of simple for the purposes of demonstration. I'm just going to grab the top plane and come back up to my ribbon for features. I'm going to create an extruded boss, and I'm just going to do sort of the standard example, a plate with some holes in it. So we'll create a rectangle at the origin. I'm going to give it some dimensions. We'll just give it 2 inches by 2 inches for the sake of demo here, except if I rotate a little, you can see that it is going to extrude. I'm going to give it a little more thickness than that. Let's give it a 1/2 inch. So 2 by 2 by 1/2 inch. And I have now a part in here. Now, if I accept this in the upper right-hand side of my model window, it's not blue over here anymore. So I'm back to the assembly bone. Now from here, I have my first part laid down. I could insert a component. It wants me to open it. Let's grab one of the plates from a previous tutorial. I can drop this in now and mate it the same way that we would with any other part. Okay, I'm going to delete it because that's not what I want to do right now. I want to first, as I mentioned in previous assembly tutorials, we don't really like this fixed being here because in this case, because I created it in the assembly, it is fixed. And if I highlight the origin of the part and the origin of the assembly, those are the same now because that's where I drew the part, right? I created it in this assembly using the assembly's axes. Best practice is to get rid of this fixed constraint. So I'm going to go ahead, right click and click on float so that it's floating. And I'm going to add a mate to the origin. So select both origins with control click and just hit mate. And it automatically comes up with coincident and align axes here on the left. And I'm going to accept that. So I got rid of the fixed and went back to sort of the old style or the previous recommendation of mating those origins just to make sure things are locked down at 0, 0. Good practice to get into again in this case because we built this part in the assembly. It's not strictly necessary like it is in a quote normal assembly. So I need some holes. I forgot about the holes that I need to put in this part. So over on my feature manager, I can right click. I can edit the part again. So we'll click that, edit the part. I'm now blue, so I'm editing the part directly. Under features, I'm going to go to my hole wizard and I'm going to select this top surface of the plate. Oop, I forget. We need to pick what type of hole we want first. So I'm going to go threaded on this plate. Bottoming tapped is fine because in this case, I'm going to leave the end condition as through all. I'm just going to punch some holes through it for the purpose of demonstration. Now on the positions tab, now I can select that surface and start dropping in the points to create those holes. So I'm going to drop a point here, 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 and here. Now, I could have done the same thing by drawing a rectangle. In this case, I wanted to demonstrate how to use some other sketching constraints to design a square hole pattern. So in this case, I'm going to control click the top 2 points and I'm going to add a horizontal constraint. So now when I drag these, notice the dots move together. I can move them closer, but they're now constrained to be horizontal. And that's sort of my normal workflow. This one isn't constrained to anybody. I can put it anywhere I want. But because these top 2 are now constrained horizontal, they'll sort of move up and down together. And that's the way I normally do it rather than use the rectangle shortcut. Either way is perfectly fine, but I'm going to add constraints to the rest of these. So I'm going to control click this dot and this point, and I'm going to add a vertical constraint because they're above each other. This one and this one, and add horizontal to my bottom holes. And this one and this one to add a vertical. Now, no matter where I go, these will be laid out in a rectangular pattern. So just another way to do it sort of without the rectangle tool, right? I can drop these points in and constrain them horizontal and vertical and effectively get a rectangular layout in the same way. Now, dimension-wise, I'm going to smart dimension between the points. And because they are constrained vertically here and here on the right and left sides, once I enter this dimension, let's call it 1.25, notice both holes on the right moved because these 2 are again constrained vertically. So I'm going to do the same thing here, 1.25, we'll just go for a square hole pattern. And then I'm going to locate this first hole based on the edge of my part. So from there, let's do 0.25. Is that in the center? No, 375 should be in the center. We did 2 inches. There we go. And the 375, again, from this point to the top. So that should give us a whole pattern that's square and is centered within our plate. So now I'm going to accept that, and I'm going to accept my changes to the part. And now I've got tapped holes through that plate in a part in the assembly. This part, again, has never been created before. I just created in this assembly. Now what I'm going to do is for the mating plate, similar to previous how-to videos I've done, on the Insert Components drop-down again, I'm going to click New Part again. Okay. Again, I get a part in my feature manager on the left that's fixed because in this case, because I haven't actually created it yet, and I've got a green check mark, so I can click anywhere. That part is now created. It just doesn't have any information with it. So again, if I right click this new part, I am going to edit the part. The first part turns transparent to indicate that I'm working on something else, some other part. I'm blue over here in my feature manager. So that tells me again that I am editing the part that I want. So now I'm going to select this top surface. And here is important. I'm going to select this top surface and I'm going to select this. Actually, it's off now. This no external references button is key to this method. So without that method, I've selected that top surface. I'm going to select sketch. Now I'm sketching on this top surface. And if I, for instance, want to draw a rectangle and I want it to be the same size as the plate, I select the corners and I'm locked down now. If I accept, I have a rectangle. I can now, since I sort of, stream of consciousness did my things in a little out of order. I can select my sketch over here from the feature manager in blue. That's the rectangle I just drew. In this case, it's square, but squares are rectangles, right? I can hop up to my ribbon and features. I can extrude, and a ½ inch is already in there because that's what I did last. I can accept that, and I now have a plate that is the same size as the one beneath it. I'm going to accept that. And notice it's still fixed because I designed it in context. So this part was built in context of the assembly. So it comes in automatically as fixed. I don't necessarily need to mate it. So now I need the clearance holes to sort of bolt these two back together. I'm going to right click the part again, edit the part. Now I could do this before I accept the entire part. That's perfectly fine too. I'm going to come back to features and my hole wizard. And in this case, I want countersunk holes. We want to add a through all end condition, that's right, but we want to add head clearance as normal, and we're just going to keep it small for now. We know that flathead screws typically need some amount of head clearance, so I'm just going to drop that in. Then position-wise, positions, and I can click my top surface and drop in my points. So I need 1, 2, 3, 4 points. Now, the benefit, this button, is no external references button. I'm going to go ahead and click that. So now no external references are turned on. So if I select this point and this sort of hole on the other part, over here I get no options on the left, right? No nothing. I'm deselecting those. If I turn off no external references, meaning external references are allowed, I can select this point and control click this other hole on the transparent part. Notice now I have options for mates, or for relations rather. These aren't strictly mates. These are sketch constraints. So I can make a concentric constraint, and notice my yellow preview hole moved to be concentric to the hole below it. Flip or rotate a little rather and do the same thing here. Click my point, control click the bottom of that mating hole and click concentric, and now the holes are lined up. And notice the dots are black because that's the only constraint that's necessary. I can do the same thing with the other two holes, control click and concentric, and rotate a little, and control click and concentric. And if I accept the changes to my part, I now have through holes and tapped holes for my 1/4-20 screws in these parts. So that is sort of in context part drawing or part modeling in a nutshell. The first part we created completely from scratch inside the assembly. The second part, now notice I left that one fixed. I could undo that and get rid of the fixed constraint, but because I sketched the rectangle that defines this plate, because I sketched it and made it coincident with the first plate's upper surface, it doesn't make a whole lot of sense to float this one, because the sketch itself is already lined up where I want it to be. So I can leave it fixed in this case, and sort of in this method in general within context parts, we want to leave things fixed because that's sort of the whole point. But now I've got it. I can drop the screws in too, right? If I wanted to insert my components and add the screw that I created for a previous tutorial, I can do that, drop it in, and I could even mix and match, right? I didn't create the screw in context of this assembly, but I dropped it in, it was pre-saved, and then I can mate it the same way as before with mates on the surfaces. And we want to be coincident. Oh, in this case, it doesn't like flathead screws occasionally get picky when we do counter. I bet sometimes it gets picky, and the reason it got picky in this case is because if I edit this part and right click and edit my hole feature, I bet I selected the wrong. I did. Type flathead screw 100. I know this screw as a standard screw is an 82-degree head. So if I change that and accept, now if I attempt to mate my countersink with the bottom of the screw, they should be the same angle, and things are happy. Notice the screw moved into position properly. So I can mix it, like I said, mix and match. The top plate, the bottom plate were drawn in context. The screw was brought in and mated the same way that we have in the past with assemblies. So in context assembly is a quick and easy way to get our parts lined up. Without having to flip back and forth between windows, right? Because this hole pattern with the countersunk holes has been defined to always be concentric with these. I don't have to flip back and forth and guess or remember what my spacing was, right? Were they an inch and a quarter apart? Were they an inch and a half apart? They're always going to match whatever the hole in the first plate was because I told it to always be concentric. The benefit to that now, if I go to the first hole, the first plate that I sort of modeled, right click and edit it. If I decide that that hole spacing isn't right, I need it to be smaller. I can right click and edit my hole wizard on this bottom plate. Under positions, now it'll take me back into the sketch. Let's say I need them an inch apart. So if I measure an inch apart and an inch apart, I'm going to leave this dimension here, this off the corner to be the same. But notice I'm not concentric anymore because I moved my holes, right? The if I rotate a little, the countersunk holes aren't concentric anymore with these holes. But if I accept my changes and accept my part, notice that the top plate automatically updated itself to match. So this is the sort of the huge time-saving aspect of in-context modeling. This is also the massive disclaimer and why I don't actually recommend modeling things this way. The problem is I changed this part, the base plate, and this is a scenario that could pop up as say we're building a machine or building an assembly. I noticed the whole pattern didn't work, so I modified the base plate and I have a new one machined. SolidWorks automatically changed the top part to match because of the way that we constrained it, except I don't know that as the person doing the machining, right? I machined a new bottom plate. And now when I bring this bottom plate over and say I already have this plate machined, now all of a sudden the holes don't line up because it updated in SolidWorks, but I didn't know that it updated. And this isn't necessarily a problem with a two-plate assembly like this, but with hundreds of parts, if everything is in context, these changes can really cascade from one part to another, and it becomes a revision control problem. If I change one part at the base, every part above it is going to get changed by default, except I don't know what actually changed, and it really leads to problems when these parts come out of CAD and go into the physical world. So again, very valid technique, very time saving, right? You don't have to flip back and forth and remember what hole patterns were, kind of stuff. Even more complicated assembly saves even more time. The problem is in that revision control and the fact that these changes, any change I make to this base plate, again, even if I edit this part and change even the size of the plate, edit feature, I take that back. I didn't want to edit feature. I wanted to edit the sketch to change the size. If I change the size to 3 inches on one side, now we actually have an error, which we didn't get before. Let's see. One of the reference is suppressed, invalid, or no longer present. That is because of these definitions of the holes. See, it tried. What happened here is it tried, and let's see if I have enough. Can I edit this to demonstrate exactly what happened here? And you're sort of real time as I record this again, stream of consciousness. You're sort of real time encountering one of the other problems that can pop up with a lot of in context assemblies. The countersunk holes, right now, there's only 2 of them because they were constrained. 2 of them were constrained to this hole and this hole. The problem was SolidWorks is trying to make them exist. They're trying to make 2 holes here, except there's no material, right? Our top plate stops short. And part of the reason that it did that, let's edit. Well, first, let's accept the changes to the part. Let it be broken for a minute. I'm going to edit this part. and I'm going to edit this boss extrude. Edit sketch. So notice we got all kinds of and part of the problem here is this equal constraint. That's part of the problem. So because I drew it as a square, SolidWorks threw an equal length constraint in here that we don't want. If I get rid of that, notice my rectangle popped out to where I wanted it to be. I wanted this to stay even with the edge of the bottom plate. Now, if I accept that, that should pop my other holes in. But again, that's a problem that pops up within context part modeling. And again, overall, if I change this base plate, everything above it cascades, and rather than having to remachine one part, or at least having the trigger to look and see what changed, because if I make a change and don't know about these in context parts, that can really be a problem as far as revision control again, and just plain not having parts work that are, sort of in the middle of an assembly when physical parts at the bottom change, but I forget to change the parts in the middle. So again, great technique. Absolutely use it, especially for like 3D printing, or if we're doing one-off and we know it's only a one-off thing. Just be very, very careful in any kind of production environment, or I mean, especially if you're worried about the version control issue. So thank you for watching. I hope this was helpful, and we'll see you back for another how-to video.